All right, here we are on a Sunday night. We're at the laptop. Time to figure some stuff out. So I have recently, PRE Racing, where I work, has become a FuelTech dealer, which is, if you've ever watched Street Outlaws, or really if you've ever watched any turbo car racing, so Outlaw 10.5, 275X, anything that runs turbos and needs power management, FuelTech is kind of just running away with the game right now. So obviously you don't want to be behind the times, you want to be ahead of the times, or at least with the times. So you want to adopt the newest, best technology. So obviously the best way to learn a new system is to have one in your hands. Mine should be here on Tuesday or Wednesday to start the install in the car. But the first step, of course, is going through the software and making a plan. So what we've got, I've got the laptop in front of me. I have a Cerveza because we're going to need it. And I'll show you why in a little bit here. All right, so let's start by opening up the FuelTech Manager here, called FT Manager. Nice pretty splash screen. This is a pretty slow laptop with a small screen, so you're going to see how terrible it looks and how slow it loads. Now this is kind of a worst case scenario, not terribly slow for this laptop, but you can see stuff's kind of scrunched a little bit. It's a little bit funny. I'm on the ground. I don't currently have a desk. I've got my sweet ostrich. We call it the derpstrich. So FuelTech software, we're going to start by making a new map. And I'm just going to run through this real fast. It might seem like a doozy and a lot of information. ECU model FT600. Yeah, we got the latest and greatest, biggest, baddest mamma jamma to run my tiny little low-powered 4-cylinder engine. This system is designed, and I have to emphasize this, this is designed for 4,500 horsepower V8 monsters. It's not built really for what I'm doing with it. The idea of running it in my car is I want to know, I want to learn it. I want to learn it the best. And the best way to learn something the best is to use it. And I don't want to experiment the first time I use this system on a customer's car. I want to do it on my car. I want to learn the ins and the outs, the finickiness, the software, the hotkeys. It's amazing when you're tuning a car how important it is to know the keyboard shortcuts. If you don't know the keyboard shortcuts, you spend time just doing basic math functions, adding, subtracting. That takes away from the amount of time you're actually tuning the car. If I've only got 2 hours, 3 hours, maybe 4 hours with the car on a dyno, I want to spend as much of that time actually calibrating, not trying to make things what I want them to do. So if I've got a table that's got 32 by 32, that's huge resolution, and I have to individually go through each cell and change each cell one by one, I'm never going to finish that tune. You know, and that's how some older EMSs are. You end up having to go through and do the math on each cell. I want to be able to highlight a whole row and do, you know, large calibrations and calculations all at once so that I can get the tune done faster. So let's just go through this real quick. This is one of the nice things about the software is it gives you this really cool setup that gets you at least close. So we are going to run O2 closed loop. For the sake of simplicity right now, I'm not going to set up any of this stuff. There's a whole bunch of things this can do. We just want to kind of go through the basics to get this thing running on the Subaru. None of that is going to happen right now. Shift light, no. We do have 2 fans, not 1. Subaru doesn't have air conditioning. Fuel pump, cold start, no nitrous. I know, no nitrous. I want to run nitrous. I should run nitrous, but we'll turn on nitrous. We got to run nitrous. We have it. We might as well use it. Let's see, boost activated output. Now, wastegate boost control, we want that. Gear change ignition cut. If I end up running the auto trans, I won't need that. We'll do some other stuff, but for this, we'll set it up. Map selection by button, pit limit, activation, flex fuel, variable cam. I want to go through something real quick here, just talk about something. Map selection by button is an interesting one. On most ECUs, you have no way to quickly change what you're doing on the car. So you've got, a lot of times you'll run multiple maps in order to be able to effectively change from one setting to another. The really cool thing about the FuelTech is, let's just click on it here, their little sales thing, sales pitch. Yeah, it's $2,600. That seems like a lot. That's without the harness, but this is not just an engine management system. This is an engine management system that includes a digital dash, but for some reason it's not loading. There it goes. So this right here is all of it. This is the computer right there. The computer is the dash. So you've got a 2 connector on the 600, 2 connector on the 550, single connector on the 450. So obviously the 450 has a lot less inputs and outputs. But what's really important is it has a dash. And it doesn't just have a dash, it has a touchscreen dash. On this touchscreen dash, you can quick change maps without having to load your laptop up or waste an input for a map switch selector. So that's super critical when you're talking about value in an engine management system is, yeah, it's $2,600, but an Elite 2500, which doesn't come with a dash, is $1,950, and then you got to buy a dash. So you're going to be in more than what it costs for the FuelTech, and that dash isn't going to allow you to do feedback directly to the computer. I can't, on the dash, just press a button and change not just the map. I can actually go in on the FuelTech and I can tune the car. I can pull up the fuel map on the dash itself, and I can change the fuel map. I can change the boost control map. I can change my boost targets, my wastegate duty cycles, anything I want, I can change. So the advantages so far in the FuelTech, it looks on paper like a miracle drug, you know, but what do they say about things that are too good to be true? They usually are. So we're going to get into some of the downsides to this system, and man, let me tell you, I was a little upset when I started going through this software. We'll get a little further first. So engine type, piston, TPS, fuel injection table, no. Number of cylinders, 4. Main map, TPS. Now here's one thing. Fuel table can only be map or TPS. Well, that's fine. Map is speed density, TPS is alpha N. Mostly that's all you're going to run on a race car. But if you were trying to run this on a street car, you might want to run it off of a MAF, but you can't. It won't let you. So limitation, there's the first one that we've come up on. Firing order Subaru, it knows what Subarus are. Kind of cool if you change this to 5-cylinder. It knows that you're running an Audi down here. If you change it to 6-cylinder, a bunch of 6 cylinders. No such thing as a 7, so it automatically switches to an 8. Now you got a bunch of V8 different firing orders, so I'll go back down to 4, select the Subaru, hit next. Now we've got our RPM signal set up. This is pretty straightforward. Subaru uses on the crank, it's always a VR differential. You could install a Hall sensor, that's fine. Cam sync sensor is also a VR on my particular engine, being that it's a version 7 JDM motor. The cam sensor is off of the cam gear, not off of the back of the cam like the US 2.5 liters. It's more like a US 2 liter with a VR sensor on the front. It also has 2 VR sensors on the backs of the cams because it does have AVCS, or variable cam timing. We'll get into that in just a second. So crank trigger pattern, it's not a 60-2, it is a Subaru new 36222. I don't know what the difference between the Subaru new and Subaru old is. I'm going to have to figure out what they're looking for there. Subaru new says 9 teeth -3. The index position is not preset in this system. It's just a default 93 degrees. The Subaru, I think, is closer to 40 or 44 degrees. You'll check that with the timing light once you get the car running. Okay, so Subaru old, 4 teeth at 0. Subaru new is going to be, it says the same. It's weird. Subaru new, yeah, 4 teeth at 0. Yeah, I'm not really sure what that means. We'll get into that when we start setting up the actual car, once we have everything ready to go. Next table, ignition, sequential, individual coils, coil and plug, falling edge. That's all correct. We're not using the FT Spark. That's their fancy Spark module. Maybe someday when the budget's a little higher, we can do that. Injectors, sequential, heck yeah. Secondary injectors, we're not currently running secondaries. Maybe in the future we will run secondaries. Primary bank total flow, this is kind of fun. This is the total fuel from all 4 injectors. So what we have to do is a little bit of quick math. So 4 injectors, we're running FIC 1650s. I have a nice website here, fuel injector calculator from Witch Hunter Performance. I already typed it in. 1650 converted from cc's per minute to pounds per hour, 157. 157.1 times 4. It's going to be 628.4. I'm pretty sure that's the number this wants. Again, I haven't actually set one of these up on a car yet, but I will soon. It may want half of that number because it says the bank flows. So usually Subarus are actually considered one bank, even though they are kind of a V4, or I guess it's a flat 4, which you would think is 2 banks, but I believe we treat them as one. The dead time on those 1650s, I don't have the exact number off the top of my head, but at 58 psi, I think it's about 0.85 milliseconds. They give you a little card when you buy the injectors. Here's a sample of one. This is from 2150s, and 2150s, 14 volts. And I'm not sure if they want the base time at 12 volt or 14 volt. I believe they want it at whatever operating voltage is, so it'd be 14. But I will confirm that, obviously, before I set it up. I'm going to be headed to FuelTech in about a month, if everything goes well, to do a training. So, not 100% sure yet if I'm going to that, but I believe that is the plan, either in March or in April. So, next one, pedal throttle, 1 TPS. We don't have electronic throttle on this car. Idle actuator is a PWM valve. It's a 1-wire, not a stepper. PWM frequency on the Subarus, I think, is 328. It's somewhere in that ballpark. Can kind of fine tune that later. Next page, generate FuelTech base map. What compression ratio are we? Well, this motor, normal Subaru is going to be like a medium compression. This motor is actually pretty high. Fuel type, just for simplicity's sake, we're going to set it at gas and we'll go from there. We are going to be running alcohol, well, at least ethanol, probably methanol. Cam profile, Subaru is pretty low profile cam. It's not a big lumpy boy. So we're going to generate this map. Yes, do you want to view the wire and harness diagram? I always say yes. All right, so there it is. Boom, wire and harness diagram. This is their base diagram. This is a 2-plugger. So there's plug number 1 and there's plug number 2. Whole bunch of spares that I'm not currently using. None. So we have a lot of available inputs and outputs. You know, sky's the limit what we want to do with this thing. I think this system will run a 12-cylinder engine. On their website, they do kind of tell you there is, under ECUs, a comparison chart that goes through all of their different ECUs and what they can do. The 450, 550, and 650. So it can run a 12-cylinder engine sequentially, I believe. Yeah, a bunch of features. Yeah, so let's get back to actually playing with this though. All right, let's go back up to the top here. First thing I want to show you, main fuel injection table. It's a 2-dimensional table by default. This is a little bit Mickey Mouse, in my opinion. It's a little insulting actually being a tuner and having them throw this at you, but the reason why they do that is because the system is built for the end user. I had to get a little beer there because it's about to get ugly. This system is built, no insult to people using it, this system is built to be simple. Simple is good and simple is bad. Simple is good because simple works. Simple means that at the end of the day, the car is going to go out and do what you asked it to do with minimal complaining, I guess. Simple is bad because sometimes you want the car to be a little bit more elegant and a little bit more accurate. The FuelTech is kind of like using the 4-pound sledge when you could have used a ball-peen hammer. You know, instead of dancing around the problem, it's just going to hit it with a hammer and get it done. That works, and this will work. Trying to be optimistic about it, but as I first dug into this, I was like, what is this? This is like 1992 called, you know, that their old AEM version 1. I actually don't know when those came out. I think it was a little later than 92, but anyway, 2-dimensional table. I figured this out. You can get rid of this. So this was a main fuel injection table, which is just milliseconds of injection time versus pounds per square inch of pressure And then there was an RPM compensation, which looks more like a VE mountain, which is the same thing. It's an offset for RPM, and you can see this kind of looks like a VE curve. You take this map, and you put them together, and it actually creates a three-dimensional map, and you can tell it to do that. So we are going to do that. You have to come down here on the side, way down to engine setup, advanced map options, and right here where it says ignition maps and fuel maps, currently it's set to line, and we want to set it to table on both of them. And then we want to set a couple other things. Let's see here, O2 closed loop, that's fine. Internal data logger is fine. Advanced traction control, we're not going to mess with that yet. RPM settings. This lets you change the voltage levels for the VR sensors, which on Subarus is kind of important. It helps you filter noise. We'll enable that. Probably not going to set that up right now, but I just like to have that enabled. We don't need to mess with the different pins for the fuel injectors and the ignition. Fuel injector angle you can set, or you can let it default to its own default, which is fine. Idle speed control, you can change the PID settings for. Same thing with wastegate pressure, you can change the PID settings for. We're not going to mess with any of that yet, but when I click back up here, it's going to yell at me and say, do you want to convert from basic to advanced? Yes, we want advanced. We're not basic. Look at that. Now we have, this is actually the same tables we were just looking at, except presented as one table. So two-dimensional tables, when you combine them, populate into one three-dimensional table. Now this looks more like a VE table, but it's not a VE table. This is a millisecond table. This system doesn't function on an airflow model. It functions purely on a fuel model. Again, this feels really kind of gross. It feels very archaic, very old school as you were, but it works. I mean, this is telling us how much fuel we need at a given RPM and a given amount of load. This doesn't work so well with air fuel targets. So like your air fuel target is going to become a fuel trim target, not actually like, it's kind of hard to explain. It's just basically normally your VE table is going to tell you how efficient your engine is, and then your air fuel target is going to tell you what amount of fuel you need. So if you know how efficient your engine is, and you know exactly how much fuel is being delivered because you've modeled your fuel injector using how much it actually flows at various different pulse widths, and you know how much airflow is going to enter the motor, and you know your desired air fuel ratio out the tailpipe, you can use some pretty simple volumetric, or just basic volumetric equation to come up with how much fuel needs to go in the motor. That includes the brake specific fuel consumption of the engine and a few other variables, the size of the motor, and pretty basic VE calculation. This doesn't use any of that. Whenever you take a tuning class, they're going to teach you all these VE calculations, and this system just throws all that out the window, which, like I said, makes it feel really archaic, makes it feel like we've gone back in time 20 years, but yet this is the, quote, latest and greatest, best system on the market. Just seems kind of weird. I guess it kind of shows you got to have the basics and the foundation, even though this kind of goes against the basics and the foundation. I look at it more as, but it's not even, I was going to say more as like carburetor tuning, except even carburetors, you tune the airflow. You know, you add fuel with a jet, but you're tuning the airflow. So it's just kind of hokey. I don't really want to get into any of this at this moment. The next fun thing that we have to set up on here is the cam, variable cam timing. So we do have VVT on this engine. We have 2 banks of VVT, and we have, what did I say, analog input Hall sensor. So this is a problem on this Japanese motor. This Japanese motor has VR sensors on the backs of the cams as well. So we're going to have to switch those to a Hall sensor because this system can't use VR sensors. So let's take a drink. We should play a drinking game. Every time this system makes me angry, take a drink. I take that back. That's a terrible idea. I'd run out of beer. All right. So basically, you're just going to have to go through this like it's a battle axe. PWM frequency 200 hertz, I think, is pretty close to accurate on the Subarus. This shouldn't be hard to set up, but it's just having to switch the sensors. That's fine. It's a few dollars, probably have some extras laying around. All right, so let's come back down here to inputs. We want to add some inputs. And here's where earlier I was going through the software and I realized something was missing. So let's see here. Two-step, that's awesome. AC button, we don't need that. So let's just fix it to something else. Now in this list, all the different things that you can run as inputs. There's quite a few. Currently we have set up oil pressure, engine temp, fuel pressure, air temp, TPS. It's got some strain gauges set up. I don't have any strain gauges, but they're just defaulted in there. There's up to 20 inputs. Whew, 20, that's pretty awesome. But we scroll down here, we have back pressure. That's fun, that's exhaust pressure. I was planning on running one of those. But this system can't actually use back pressure for much. So we can log it, that's great. It's a really cool logger, but the more modern way of doing even volumetric efficiency on a motor is to say, what is my intake map pressure over my exhaust map pressure? That's IMAP over EMAP. And you do that equation and you actually come out with the real efficiency of the motor. How much air is going in and how much air is coming out. That's going to tell you exactly what the volumetric efficiency of your engine is. This system doesn't care about any of that. Again, basic instead of complicated. So let's see what else we can put down here. Brake pressure, we're not going to run that. Sometimes you can do some fun launch control stuff using brake pressure. Clutch position, clutch pressure, dash button, data logger. Like I said, we don't need any of that because the dashboard will let us do all that stuff. Drive shaft RPM. Ooh, EGTs. If we were running EGTs, that'd be great. Exhaust temperature. We don't have exhaust cam. Physical position. We don't have a thing there. We don't have fuel flow. Fuel pressure is already set. Generic outputs now. High beam, ignition. A lot of stuff. Map is an interesting one because there is a map sensor on the throttle body on this car, but there's also a map sensor on the ECU. When we go back to the picture of the computer itself, there is on the back of the computer a map sensor. They recommend you run their map sensor. You don't try to wire in your own. I've had various success running the map sensors on the ECUs just because of the length of the line and trying to get a good average signal on a 4-cylinder. But I'll probably try it first on theirs, and then if I need to run mine, I will. All right, so we were down at map. Let's see here. O2, we want O2 general. That's fun. There's your wideband input. Now we need, what's another one? Oh, we want flex fuel. Yeah, flex fuel. All right, so we're basically, and then over here you can set up the actual type of signal. So flex fuel sensor, this is just a default. If you wanted a custom digital, analog, various different inputs, you could set it up, enable pull up, lets you do a lot of stuff. Digital sensor, pulse falling edge, so if it's frequency sensor, you can set it up there, which most flex fuel sensors are. I'm assuming their default is for a frequency. I don't actually know that. If it is for a frequency, you should be able to run fuel temperature as well. I didn't see, yeah, I see flex fuel. I don't see fuel temp, but it might automatically pull it in. If it does, then that's awesome. Let's go back to high beam switch. Why would you want a high beam switch? Well, a lot of cars have electrical issues and the high beams might require more idle. So you can run a high beam switch. Oh, let's see here. Tire temperature, that's kind of fun. Bunch of traction control stuff. That's where this system is supposed to just be absolutely epic, as the traction control. But I don't see, let's go back up here. Wastegate pressure, that's fun. Right in here somewhere, there should be something that starts with a K and ends with OC, also known as knock. This system has no knock control. I'm going to say that one more time. This state-of-the-art, top-of-the-line engine management system doesn't have knock control. Now, I know a lot of big power cars don't run knock control because why would you want to pull timing? If you had needed to pull timing, you must have done something wrong. You must have tuned it wrong. There's something that you didn't do right, and that's why there's knock. Well, unfortunately, on a street car, there's always conditions where you're going to get some knock. And it'd be nice if the computer could just pull a little timing and save the day. But it's not even going to let you have the possibility of even the most rudimentary knock control. They just don't even have it. They don't even care. No knock control. So this really upset me when I figured this out because I've already ordered this system. It's already on its way. It's mine. I guess I could send it back, but that'd be kind of silly. So I had to think about it for a minute. Well, knock control, while I think it's important, I feel like it's important, even on the best tuned engine, I feel like it's a good thing to have. What else can we do that's going to give us some safety? And for all the people saying, well, you shouldn't need knock control if you tune it right, well, by that definition, you shouldn't need an oil pressure sensor or an exhaust temp sensor or an air temp. I guess you need an air temp sensor, but you definitely don't need an O2 sensor, because if it's tuned right, why would I care what the oxygen, the air fuel ratio is? Why would I want closed loop O2 control? You know, why would I need oil pressure safeties? If the engine's right, then it's right? No. Safeties are good. Safeties save us money. At the end of the day, we don't all have $100,000 budgets for a race weekend where we can throw 2 or 3 motors at the car if something's not right. I'd rather lose, you know, a couple of tenths on a pass than drop the motor at the 8th mile. So what can we do? Well, a couple of things that you can do are some various pressures. So it doesn't have it defaulted that I see. No, there's not. But one thing that you can monitor is coolant temperature. Sorry, not coolant temperature. One thing you can monitor is coolant pressure. So if you monitor coolant pressure, it's going to tell you if you have a significant amount of knock, because almost always when there's knock in a cylinder, the cylinder pressure just goes through the roof, just absolute max. And when the cylinder pressure maxes, most of the time the coolant pressure goes up quite a bit. So what we want, oh, there it is, engine coolant pressure. There we go. So you need a sensor to put into the cooling system, typically somewhere in the cooling jackets near the head, ideally, to monitor coolant pressure. Another thing that is, I feel like it's just as good, if not better, is crankcase pressure. Now, I'm not sure if I saw that one here. No, I didn't. So here's all the ones that are pressure related. It doesn't have one for crankcase, but you could run a second engine coolant one. So you actually run 2. Oh, well, let me do that. That's sad. I guess, back pressure now. Yeah, I don't see transmission, wastegate, torque converter, oil pressure, nitrous bottle pressure, fuel, brake, clutch. So they don't have one by default. It doesn't mean we can't make our own. They should have a generic. So we have generic, that's where outputs. We want inputs. Let's see. Well, what's a generic output one? What's it going to let me do? Yeah, input sensor. So I don't know why they call it an output, but we can set up our own sensor for a crankcase pressure. And what you'll notice as well is almost always when you have extremely high cylinder pressure, quite a bit of it is going to sneak past the rings. And that cylinder pressure is going to show up in a crankcase pressure where you'll see a sudden spike and then it goes away. That's knock. In almost all cases, if you're logging crankcase pressure during a knock event, you see a significant spike. You might see 3 or 4 pounds, maybe 5 pounds of crankcase pressure during a normal pull. You see knock, you'll see 15, 16, 17, 18. I've seen knock events that hit 20 pounds of pressure in the crankcase. We can set with that like a sustained, if I see knock if I see a crankcase pressure above a certain amount for 10 seconds, I want to pull a bunch of time. And by pulling a bunch of timing, it's going to allow me to save the motor, or drop a bunch of boost or something. Again, I'd rather, at my level of racing, I'd rather honestly lose a race and save the motor. You know, if I hit a safety, I hit a safety. If it's the final run, you can go in and turn these things off. You know, if it's for all the beans and potatoes and you've got 2-3 grand on the line with the final race, turn off your safeties. Let her hang out, you know. But if it's a qualifying round or just a preliminary run, you want to finish the day, or at least you want to be able to take the car home and have a good race. You know, let's run some safeties. So it'd be really nice if in the future they added some knot control. I don't know if they will. It seems like if they were going to, they would have already done it. But hey, you know, win some, you lose some. Last thing I wanted to set up, this is another one of the things that they are super well known for. It's their boost control. Now, they're very well known for their CO2 boost control. Again, I'm not going to run CO2 boost control because this is a semi-street car. So I would rather run intake manifold pressure for the pressure source and then a single valve. Not a dual two-way valve, but a single three-way. Dual two-ways are pretty cool. Might end up running a dual two-way down the road, but at this moment in time, I don't think that that's what I'm going to do. They have some pretty cool control schemes. You can set a single wastegate pressure target, or you can do time-based after validated launch, and then you go through and you set up what a validated launch is. And we'll get into more of the settings of this individual stuff once I actually have the EMS in the car wired in and ready to go. But for now, this is the more basic thing. And what we're really trying to do here is we're trying to generate a good wiring map. So now we've pretty much set up everything we're going to be running. Here's that wiring map. If you come down here and hit print, it's going to pop up, print preview. You can zoom in here and just kind of show you what we got. Oops, not 150, but 100. So, you know, here's all of our wiring schematic. You can see there is a ton of unassigned things, none, you know, but we got a lot of extras. If we ever decide to do a V8 project with this car, hey, we've got the engine management for it. So that's one of the nice things about a good standalone, is it's not specific for your car. It's just specific for you want to have a standalone. And so get it wired in, get it set up. You decide to switch to a different engine, get it wired in, get it set up. It's the same engine management. If I switch to an H6, I could run that. I could run an H6 with dual injectors because I have 12 injector channels on this thing. So it's pretty sweet. Let's see, what else do we have? Yeah, so we've got, that's the page 1, page 2, generic outputs, engine oil pressure, back pressure, can high, can low, TPS, fuel pressure, air temp. I don't see a few of the things that we do need. I don't know why it didn't populate them in here. So let's go back real quick to, let's just go to like the cam options. There we go, camshaft sensors. This is what we didn't actually grab. Single tooth sensor, they're multi-teeth. There's 4 teeth on there. They are 90 degrees apart. One of the things that this lets you do is you can set it up like that and hope that you're right, but it actually has, if you scroll down here, a wheel decoder. So you crank the engine over, running this wheel decoder. It's going to be pissed off right now because I don't have the computer connected, but as you're cranking the engine over, it's going to detect the teeth where they are on the cams, essentially meaning you can run any type of cam or any type of cam trigger. The key is if you're going to use it for sync, so for getting your actual position of your engine, the cam teeth can't all be in the same spot. So on this cam on the back side, it has 4 teeth, but they're evenly spaced. It wouldn't be able to use that to know where the engine's at. But on the US models, the cam teeth, there's 3 of them, and then there's a gap. And because there's that gap, it can use that to figure out where it's at. It's going to do that on the front of the cam on this car. There's 2 teeth that are 90 degrees apart. and then there's the rest of the thing that's empty. So anyway, you would tell it multi-teeth, multi-teeth, and then we would run the wheel decoder. What else do we got? We don't have exhaust, so there's that. Then there's targets for that. We haven't set up any targets. Anyway, analog. Yep, we're set there. I don't know why it didn't populate on the wiring diagram. At least not that I saw. Fuel injection, cylinder 1 injection, PWM idle, cylinder 2 ignition, cylinder 3 ignition, cylinder 4 ignition. None, thermofan, fuel pump, chassis ground, tack output, none. Huh. That's kind of weird. And then we've got cam sync reference, fuel pressure, cam sync signal input, then crank sync, chassis ground, 12-volt sensor ground, can, ground for sensors, TPS, engine coolant pressure, generic output, strain gauge, flux fuel, engine temp. Yeah, I still don't see those cams getting populated. So did we miss something? We must have missed something. Oh, outputs. Boom, there we go. All right, so here's where we're missing our outputs. Oops, ECU disconnected. It looks like I have to connect it, but here's all those outputs that we didn't have set up. So I have to basically go in and individually assign where we want them, which here we go. Here's our intake VVT1, and then intake VVT2, and so on and so on. Pretty straightforward. I just hadn't done it. So that's how you assign the inputs as well, or sorry, the outputs as well. So I'll have to go through and check and make sure that everything has its output, but boost control needs an output. Yeah, but there you go. So that's the basic setup on the FuelTech, and kind of my pros and cons. Pros, it's easy to use. The actual cost of it, while it seems high for what you're getting with the dash and a data logger and essentially a laptop included, it's actually a pretty good value, especially if you go to the 550 model, which is quite a bit less expensive. Click on that guy. Yeah, so the 550 model is $900 less. And for this, you get a dash and a computer and a ton of inputs and outputs and a ton of good logic, but you don't get knock control. The engine safeties, there is engine safeties in this. It's not like there aren't engine safeties. It just doesn't have knock. So, yeah, it's just kind of a sad thing that it doesn't have knock. Oops, that's idle actuator. But hey, it has wheelie control, which we need. We don't need knock control, but we definitely need wheelie control. So hopefully you guys learned a little bit on this video. Hopefully I wasn't too bummed out for you all. It is a little bit sad seeing that the modern best of the best is also the least advanced as far as its actual what it's doing behind the scenes tuning the car. It's very rudimentary, very simple, very basic. But because it's very simple and very basic, it gets the job done really well, instead of overcomplicating it with lots of math. There's a lot less math in this. This is the engine management for the math challenged. But yeah, it'll work. It'll get the job done. And as you can see in pretty much any racing anywhere right now, it's fast. It works really well. These traction controls, wheelie controls, time-based compensations are spectacular, like unparalleled with everyone else's technology that's on the market. So yeah, and it's easier to set up, which is another big selling feature. So this video has already gone pretty long, so I'm gonna let you guys go, but look forward to, in the very near future, actually getting this wired in. Like I said, it shows up sometime mid next week. So happy tuning everyone, and have a good Sunday night. Bye.